Good. See? That's what? I thought that. Yeah, good stuff. I'm Marcel Jackson, a mathematician at the Trobe University. We're going to look at some unusual algebras. This is going to be an algebra that's used in scheduling events, essentially. So we're going to look at an algebra before and after, which is probably the simplest thing we could look at here. So, for example, I might brush my teeth before I go to bed. On the other hand, I might brush my teeth before going to bed, but then I go to bed after I put on my pyjamas. So what does that tell me about brushing my teeth in pyjamas? You might guess it doesn't tell you very much. I could have put on my pyjamas first, before teeth, or after teeth. And that's exactly the kind of thing that this algebra will tell us. So it's not supposed to replace necessarily our own human reasoning, but it's the kind of thing that a computer might use to work concretely. So we're going to have before, after, and simultaneous. Before, after, simultaneous. So what happens when we compose these? What's going to go in here? It turns out it will be a before. So this will correspond to a situation where we have two events, x and y. It could be teeth and bed. And we're being told that x is before something. I'm going to use a little semicolon here. That's before something before y. So x is before something that's before y. And if you have a think about it, being before something, it's before something else, just tells you that x is before y. It tells you nothing more than that. So that's why when we compose a before and a before, we just get a before. On the other hand, if I deal with a situation where x is before something that's after y, so this means x is before something that's after y, then this tells us very little about the relationship between x and y. This is like I brush my teeth before, for example, going to bed, which is after I put on my pyjamas. It tells me nothing about if I put my pyjamas before or after brushing my teeth. So in here, we're going to need a symbol for or. We could be after, so I could have put my pyjamas on after the teeth. Or, and I'm going to use plus for or, we could have been before, or we could have actually done them at the same time. Now, actually, the practicalities for that, in the case of pyjamas and teeth, have to be sorted out. But for just abstract events, we don't really know. They could have been at the same time. If you're before something that's at the same time as something else, so if x is before an event that's at the same time as y, then clearly that just tells us that x is before y. So we get a before here. And we can work through like this. This one also gives us, I'm not going to calculate all of these. After is just the same as saying after. And after at the same time is after. And we can complete this one nice and easily too. So this little abstract algebra, which is clearly just some weird thing, tells us a lot about how to reason about before and after. The idea with something like this is that it's small, finite, and a computer can have this information built into it, and then it can reason about how to schedule events. So over here I have a little example. Little x and y are supposed to be some events, and we're asked, for one reason or another, to try and find if we can do this kind of information. X is supposed to be after or at the same time as something that's before y. A bit hard to comprehend really, but what I'm going to do here, or what I have done here, is just use the algebra of these relations to deduce. So I worked through here, and I've simplified it down using this table to a situation that says that x is after or before or at the same time as y. Apparently, x and y are completely unconstrained by this. After or before or at the same time, it tells us nothing. So this was a bit hard to understand, but using the algebra, we simplified this down. And that's how a computer can use this kind of information in the table to reason about scheduling of events.